Hello everyone. So we're going to wrap up Unit 6 Part 1 by multiplying some special case polynomials. You just learned how to FOIL or reviewed how to FOIL. There are some special circumstances where some interesting things will happen. All the rules still apply, but they look a little bit different. So this goes with assignment 5. So the first thing that we want to talk about is the perfect square trinomials. So we're going to create a perfect square trinomial by the problem that you see here. So it says n plus 3 in parentheses squared. And I'm going to tell you, nothing makes me crazier than when someone writes down n squared plus 9. That is 100% not true. No. So what we're missing here is, underneath all those scribbles, we're missing a middle term, okay? So what we really need to do when you see something in parentheses squared, what that tells you is that you really are multiplying that entire thing, n plus 3, by itself. Okay, so what you want to make sure you do is write it twice. And then once you have written it out twice, you can see that it looks like a FOIL problem. So that's what we have to do afterwards. So now that you've written it out twice, you have first n times n, which is n squared. Outside n times 3, so plus 3n. Inside is 3 times n, so another plus 3n. And last is a plus 9. So by combining like terms, we get n squared plus 6n plus 9, which is not the same as n squared plus 9. You are missing that middle term when you don't FOIL, which can cause you to get a lot of stuff wrong. There is a shortcut to think about, so instead of writing it twice and FOILing, what we really figured out back there is that yes, you are squaring the first and the last, so you have always the first thing squared and the last thing squared. But you end up with this middle term, and what the middle term does is it takes the power of 2 and multiplies it by the last term and the first term. So the middle term is going to be 2 times b and times a, and whatever is there is what you're going to multiply. So 2ab is how you generate that middle term. So you can use that to help you when you're getting and doing a lot of these and you want to get a little faster. The other type of special case is a difference of 2 squares. So that's what we're going to create here. And when I say 2 squares, those are 2 perfect squares. So 2 numbers that are perfect squares. And a difference means you're subtracting those. Well, the problem that I have in front of me, x minus 3 and x plus 3, again, we need to FOIL, right? So you get x times x, or x squared, x times 3, so plus 3x, negative 3 times x, which is negative 3x, and negative 3 times positive 3 is a negative 9. A little different than the previous problem because these two terms here, instead of adding them to get plus 6x, these are opposites. And so a plus 3x and a minus 3x, that's really just 0. So what I'm ending up with is x squared plus 0x minus 9. But we don't really have to write 0x. That's sort of silly. So we just have x squared minus 9. So you see the 2 squares, x squared and 9 are perfect squares. And the minus is the difference in the middle. So the shortcut, when you have 2 binomials that have the same exact numbers but opposite signs, is that you're going to square the first, so a squared. You're going to square the last, so b squared, and there's always a minus in the middle. All right. And lastly, one that's a little bit more complicated, but we can use that trick that we just learned. We can take our first term, 8a squared, and square it. So we notice we have the same 2 binomials, just opposite signs, 1 plus and 1 minus, so we can use our difference of 2 squares rule. Minus in between, and then the last term is 4 squared. Well, remember when you have a power raised to another power, like we do here, you're doing 8 to the second power, so 16. And then a squared to the second power. In power to a power, you multiply your exponents, so 2 times 2 gives me 4. 16a to the fourth. And then minus, and 4 squared is just 16. If you didn't recognize that this was difference of two squares, you can certainly just go ahead and FOIL first, outside, inside, last. And so you'll get this, 8 squared is not 16. It's 64, a to the fourth, minus 16. My fault. Anyway, so when you multiply, you get, when you're FOILing, 8a squared times 8a squared gives you 64. A to the fourth. And then 8a squared times negative 4 is negative 32a squared. Inside we have positive 32a squared, so you can see that those are going to cancel. And last you get the minus 16. So those two middle terms cancel out, and you're just left with 64 minus 16, which is the same thing that we got using our shortcut. So either of those methods will work.